This video includes a paid sponsorship from Span, but I'll talk more about that later. A new Tesla patent application was recently published that describes a change in the construction of Tesla's 4680 battery cells that makes them more energy dense while also being easier to manufacture reliably and likely will make these battery cells a bit cheaper as well. So stick around as I dive into this important 4680 battery update. You're not going to want to miss this one. I'm John, and this is Cleanerwatt. At their Battery Day event back in 2020, Tesla claimed that their new 4680 battery cells would lead to a substantial range increase. However, the standard range all-wheel drive Model Y, which is equipped with 4680 batteries and a structural battery pack, that vehicle only has an EPA-rated range of 279 miles, which is 51 miles less than the long-range all-wheel drive Model Y, which is the equivalent 2170 battery-equipped version, due to lower than expected energy density of these 4680 first-generation battery cells. For comparison, based on the best available information that I have right now, I estimate that the gravimetric energy density of the Panasonic 2170 battery cells that Tesla puts, for instance, in the long-range all-wheel drive and the performance Model Ys that are manufactured here in North America, I estimate that that number is right around 263 watt-hours per kilogram. We know from official EPA documents that once you actually put those battery cells into a battery pack, that pack for the long-range and performance Model Y equipped with these 2170 batteries has a gravimetric energy density of 180 watt-hours per kilogram. When it comes to Tesla's first-generation 4680 battery cells, that gravimetric energy density number is actually closer to around 244 watt-hours per kilogram at the cell level, according to the limiting factor. And when you extrapolate that out to a pack-level energy density number, I estimate that it's just a bit under 160 watt-hours per kilogram. Because of this, a Model Y with 828 battery cells, like the standard range all-wheel drive Model Y, that likely has a usable capacity of around 67 to 68 kilowatt hours and a total battery pack size of just a bit under 72 kilowatt hours, which is around 10 kilowatt hours less than the 2170 equipped version. And it's not that Tesla just specifically chose to put a smaller battery pack in this vehicle, because if you actually look at the weight of each of these Model Y variants, the standard range all-wheel drive version only weighs around 7 pounds less than the long-range all-wheel drive version. Now, of course, there are a number of ways that Tesla can raise the energy density of these battery cells and thus increase the range, the EPA-rated range of a 4680 equipped Model Y. Like, for instance, introducing a small percentage of silicon into the anode of the battery, which should happen eventually because they talked about this at Battery Day. However, in addition to an actual chemistry change like that, this recently published Tesla patent application reveals how a simple change to the construction of the battery cell itself should lower the weight of the battery cell and increase the volumetric and gravimetric energy density of the battery cells, which in turn should lead to an increased amount of range for 4680 equipped vehicles. So with that being said, I'm going to go ahead and walk through what this patent application details about this new design and some of the benefits of it. But before I do that, I want to introduce the sponsor of today's video. Thanks to Span for sponsoring this video. The Span Smart Electrical Panel is beautifully designed on the outside and expertly engineered on the inside. Span was founded by a team of former Tesla engineers who helped develop the Powerwall, Megapack, and Solar Roof. In addition, Span's founder and CEO, Arch Rao, was head of products at Tesla Energy before founding Span and creating the award-winning Span Smart Electrical Panel. Remotely monitor and track your energy usage and gain circuit-level control with a smart panel from Span. To find out more and get a quote for your particular situation, go over to span.io or click the link in the video description. And when you do fill out that form to get a quote, make sure that you let Span know that John from Cleanerwatt sent you. This patent application starts off with Tesla describing a traditional battery cell construction, and I believe this is the basic cell design that Tesla used for their first generation 4680 battery cells, like the ones that Jordan from the Limiting Factor YouTube channel got his hands on and had analyzed. Here's Tesla's description of a typical battery cell with a crimped closure design. Typical battery construction includes a can, the jelly roll contained within the can, a battery cap which is crimped to a can, and various interconnections and insulators. This structure is fairly simple, but has a number of problems. Tesla then goes on to describe very specific problems caused by this crimped design, like for instance the fact that, quote, crimping the battery cap to the can often damages the jelly roll. Tesla then goes on to describe another downside with this typical design by bringing up the fact that the top insulator in this battery design is only held in place by the crimping itself, and because of this, it must be made of a very rigid material, which in turn reduces the amount of space that is available for the electrode jelly roll. Thus, it decreases the energy density of the battery cell. Tesla then goes on to bring up a third disadvantage of this design, which once again involves the separator itself and kind of that weak connection that's made with that crimped design, which, as they say, quote, can lead to premature failure of the battery. Tesla did provide two technical drawings to illustrate this crimped design, one with a button top and one without. Moving on from that old design, Tesla then goes on to describe two slightly different variations of a new design where the battery cap is welded to the can to create a seal instead of being crimped shut, which eliminates the potential damage that was previously possible from the crimping process. Tesla then goes on to mention a second benefit because this new design allows for a cheaper, thinner insulator, which apparently reduces the cell cost. Now, I don't know how significant of a price reduction just a simple insulator change comes down to. However, when we're talking about terawatt-hour scale battery production like Tesla has talked about, even if you save just a few pennies per battery cell, that starts adding up quite a bit. So any minor change with cost does have the potential to save Tesla quite a bit of money in the long term. Now, when it comes to the third benefit that Tesla brings up about this design, I believe this is really the most important benefit from this design because Tesla mentions how the new battery cap design has a lower profile, which reduces the weight of the battery cell and makes a larger amount of space available for the electrode jelly roll, which allows Tesla to increase the size of the electrode and thus increase the amount of energy that can be stored in each battery cell. When you're able to decrease the weight of a battery cell and also increase the size of the electrode of that battery cell, that leads to both a volumetric and a gravimetric energy density increase. Tesla then goes on to describe the fact that as a fourth benefit, this new design now features a hole in the middle of the top can, and this hole can, for instance, be used to add the electrolyte solution to the battery before this little hole is capped off and sealed. Now, in addition to that first version, Tesla then goes on to describe a second, slightly different version of this battery design. And while Tesla's descriptions of these two variants is very similar, if you examine the technical diagrams that Tesla includes for these two designs and you look at them side by side, there are a few noticeable differences. Now, I don't know all the ins and outs and how significant these changes are, except for the fact that I did take these two images and line them up side by side. And if the scale is actually correct, which I believe Tesla would have included these diagrams with equal scale, as you can see there with red lines, that represents the thickness of this cap for this iteration number 1 and iteration number 2. And the second design apparently has an even lower profile cap, which once again allows for even more room for the electrode jelly roll and a further increase in the energy density. When you compare the second iteration of the second generation design to the first generation design, you can easily see how much more compact this new design is versus the old crimped design, which once again makes room for a longer electrode jelly roll. Now, when it comes to just how much this new design will increase the energy density of the 4680 battery cells, I don't have that answer. However, once again, even without adding silicon to the anode, which I believe Tesla will eventually do, without even doing that, I believe this gets Tesla closer to what I believe was their original target for how much energy they wanted to be stored in each one of these 4680 battery cells. And I believe that target was 98 watt hours per battery cell because not only is this a number that @TroyTesla wrote on Twitter back in February of 2022, but also if you do the math, if you have 828 battery cells that are each 98 watt hours each, that gives you a battery pack size of just a bit over 81 kilowatt hours. And based on some rough math, if Tesla is able to get the 4680 battery cells to 98 watt hours each, each. That should allow for the 4680 equipped Model Y range to go from 279 miles to somewhere around 330 miles, which once again would be on par with the 2170 non-structural battery pack equipped Model Y. Now the good news is that I believe this new second generation battery cell design is already in production at Gigafactory Texas, because at Tesla's recent Investor Day, Tesla talked about the space efficiency of their new 4680 battery production processes versus the 2170 battery production. And down at the bottom, you can see that the 4680 battery cells coming out of their Fremont test facility have 16 parts and 23 processes, whereas the 4680 battery cells being built at Gigafactory Texas and in the future at Gigafactory Nevada, those batteries instead have 15 parts and 21 processes. So to wrap all this up, once again, I believe that this new second generation battery cell design is already being produced at Tesla's Gigafactory in Texas. And I believe it's no coincidence that the Cybertruck is going into production very soon, sometime later on this year, likely sometime in the middle of the summer. And I believe the Cybertruck will require more energy dense 4680 battery cells. And hopefully this new design increases the energy density of those batteries such that Tesla can reach, for instance, somewhere around 500 miles for the tri-motor version of the Cybertruck. Do let me know what you think about all this in the comments section below. I'd love to hear from you. And also, I want to say once again, thank you to Span for sponsoring this video. And also, thank you to all of those of you who support me on Patreon. Your monthly support makes a big difference and really helps make these videos possible. If you're listening to this and you'd like to find out more about how you can support my work and the Patreon community that I've set up, I'll put a link in the video description so you can check that out. Thank you so much.